Good morning, students. Today we are meeting in the virtual classroom for class 10th. It is being organized by your own institution, St. Paul Modern School, Bakri Bazar, Begusai. Today we will start discussing. It will need 2 or 3 periods to complete the lesson, but we will start with the first chapter in your chemistry book, that is chemical reactions and equations. In this chapter we will learn about the chemical changes, different types of chemical reactions, and how to write down this reaction in the form of equations. Let us start a little earlier. Let us recap a little bit. 2 words. I want you to remember 2 special words that we often confuse in our daily life. One is matter and one is substance. Although we are reading sciences about these 2 things, but we often confuse in the daily life. We mean matter but we call it substance. We mean substance but we call it matter. So let us first recap the definition, basic definition. What is matter? Matter is something that has mass and that has volume. Matter is anything that has some material in it and it occupies some space. So matter is something that you can feel, that you can see through 1 or 2 or 3 of our sense organs. The things we see, the things we can feel, like air. Air we cannot see, but air also has some weight, you know. You will take the weight of a deflated football and then inflated football, the weight will be different. So these are matter. But what is substance? Substance is when you begin to classify matter either according to the physical characteristics or according to the chemical characteristics. In science we call it physical properties and chemical properties. We begin to call this classified matter substances. According to the physical properties, matter can be classified into 3 types of substances: solid, liquid and gas. This you have already read in the class 9 syllabus. I am just reminding you of it. According to the chemical properties, matter can be classified into basically 2 groups. Pure substance and impure substance. Pure substances are made of only one kind of atom or molecule. They can be either elements or compounds. And impure substance, mixtures, colloids, heterogeneous mixtures, homogeneous mixtures. You have read about these colloids, dissolution, gel, salt. You have read about the impure substances, mixtures, etc. in the class 9th also. In class 10th we will deal with the pure substances. How pure substances are formed and new substances are coming. What? Elements are made up of one kind of atoms and they also form molecules but with the same kind of atoms. And compounds. Compounds are made up of different kinds of elements and also compounds. Now, there are changes in our daily life if we give some examples. Like say, your melting some ice. The ice is being melted. It becomes liquid in form. Again you go on heating this ice, this water. The water will very soon turn to vapor. But is there any new substance formed in these changes? No. The chemical composition, inner composition of the main substance is still the same, H2, just the form has changed. Suppose you take a glass of water and mix some sugar in it. The sugar will disappear and the water becomes sweet. But is there any new substance? Has the chemical composition of the sugar, that is glucose, C6, H12O6, has it been changed? No. H2O water, has it been changed? No. So in these changes, no new chemical substances has been produced. No new substance has come into being. Such changes, which do not create any new substance, are called physical changes. Physical changes. We are not dealing with physical changes, we are dealing with the chemical changes. So what is chemical change? Chemical change is very easy, that's the opposite of physical change. Chemical change is that kind of change where the chemical composition of the substances are changed. Some new substances with the new property is created. Let's take an example from our daily life. Suppose you take some potato, take some oil, they have some definite chemical properties. But the moment you give them heat and cook them for some time, it becomes fried potato. It is something else. You cannot bring back the original potato and separate the oil from the fried potato. A new substance has been created. If you take food, you chew it, and it goes inside the body and gives energy. This change, you cannot bring back that food that you had originally eaten. You keep some iron nail outside, it will take some rust. You cannot bring back the original iron nail. So, in these cases, you are making chapati, taking dough, making dough with flour and water. You cannot bring back the original flour once you have mixed it with water. These changes, which produce some new substances, are called chemical changes. And what is chemical reaction? Chemical reaction is the process by which a chemical change occurs. A process by which some elements, some compounds, they change their previous properties and form substances with new properties. This process is called chemical reaction. The basic differences between physical and chemical change. In physical change, the change is temporary. In fact, physical change is reversible, easily reversible. But the chemical change, the change is usually permanent. It is almost an irreversible process. In physical change, no new substance is formed. There is only change in the physical properties. But in chemical change, new substances are formed with entirely different physical and chemical properties. Number 3. The physical change can be reversed by simple physical methods. But chemical changes cannot be reversed by simple physical methods. They involve a lot of difficult chemical processes to reverse the process. Number 4, energy may or may not be released or absorbed. But during a chemical change, energy is always either released or absorbed. Chemical reaction is either endothermic or exothermic. And the last basic difference between a physical change and chemical change is during physical change, most of the time, original form of the substance can be obtained easily by simple physical methods. But after a chemical change, the original substance cannot be obtained by simple physical methods, right? Now, let us come to it. Suppose we are taking an molecule of hydrogen, H2, and one molecule of water, and making them, changing them into H2O. Actually, this is an unbalanced equation. We are going into that very soon. Let's just keep it balanced for the time being. We'll talk about it later on. Point is that, now what I am trying to tell you at this point, hydrogen is an element. You know that. Oxygen is an element. What kind of elements? They are gas. They are gases. And what else? Hydrogen burns. The gas burns itself. And oxygen helps burning. Now when they are mixed according to a certain proportion, definite proportion, water is created. What is water? Water is liquid. Does water burn? No. Water actually is used to put out fire. You take oxygen to breathe. Unless there is oxygen in the air, we cannot survive. But inside the water, you cannot breathe. You see, this kind of changes, when the properties of the previous things that had chemically reacted produces a totally new substance with new properties. This kind of change is called chemical change, and the process is called the chemical reaction. Am I clear up with this one? Now, the substances which take part originally, we have to learn two words: reactants and product. Product or products, no problem. There can be more than one product, we will say. And there can be one reactant also, sometimes in decomposition reaction, we will see later on. Let us go step by step. So, what is chemical change? The type of change where new substances are produced with new properties. And the process is called chemical reactions. The substances that originally take part, that initiate the chemical reaction, are called reactants. In this reaction, hydrogen and oxygen, these two are reactants. And the new substance that is produced, is the product. Am I clear on these 2 points? Let us come to the next point. What happens is that new substances are formed. Now there will be type of reactants. Let us clarify on this point a little more, right? We can mix up, like we said, element, take two or more element and produce a compound. This is the first kind of chemical reaction. One example is that one I had already given you. An element combines with another element to produce a compound. So you can understand logically, we can also combine an element with a compound to form another compound. It is the second type of chemical reaction in their basic form. What is the example? We deal with this example a little later, but let me give the example here also. Suppose we take zinc, it is a real element, and add some diluted, say, hydrochloric acid. It's a compound of hydrogen and chlorine. What will we get? We get zinc chloride and H2 gas. You see, we mix up one element and one compound to produce another compound. And the third kind, suppose we take one compound and react it with another compound plus compound, and that also makes a compound, right? Let us give some example. Suppose we take some barium hydroxide. It's a compound, obviously you see is made up of three elements, barium, oxygen and hydrogen. And we mix it up with ammonium chloride, which is itself made up of three elements, nitrogen, hydrogen and chlorine. What will happen is that we get barium chloride and ammonium hydroxide. Here we get compound plus compound reactants produce a compound product. These three kinds can be made into compounds. Elements to elements into compounds, elements and compound to compound and compound to compound. Again makes a new one. These are the three basic part of the chemical reaction. Now, if you have understood up to this, let us also remember one basic point. Before that, let me give you some more examples with some slides how this kind of different kinds of experiments actually happen in the laboratory, right? Let us see what chemical reaction is like through some experiments, actual experiments. When you come into the classroom, we can organize in the laboratory. Here you have to be satisfied with the slide. But let us see magnesium oxide, how it is formed, and also some such slides I have prepared for you. Let's go through it first, okay? Look at the slides. this is the burning of magnesium ribbon in air. Magnesium metal is generally available in the form of a ribbon or wire. If we burn it in the air in the presence of oxygen, a kind of ash forms which we call magnesium oxide, Mg plus O equal to MgO. In this reaction, we have already talked that we mix zinc granules Zn with either sulfuric acid or hydrochloric acid to form zinc sulfate and hydrogen gas or zinc chloride and hydrogen gas. You see, zinc plus sulfuric acid leads to zinc sulfate, a colorless solution, and hydrogen, a gas. And if we mix hydrochloric acid with zinc, we get zinc chloride, which is also a colorless solution, and hydrogen. In this context, we must also maintain that two major processes. One is photosynthesis, which is very important chemical reaction. In photosynthesis also, you know that the carbon dioxide gas mixes with H2O water, and in presence of chlorophyll and sunlight, it produces glucose and also oxygen gas. In the same way, the respiration done in the animals, all organisms including plants and animals, it also involves a very complicated chemical change. It breaks down glucose by burning it with oxygen in our cells and releases energy with carbon dioxide and water. All are examples of chemical changes. So, if up to this you are sure about that, you have got it properly, let's come to the next point. Chemical reaction produces new substances, but I am here remind you that there is no new mass is created, no new matter is created, because you have already read in the previous classes, there is a universal law, the law of conservation of matter. No new atom, no new can be created by any reaction in this world. The conservation of matter, conservation of mass, these things you have already learned. So, the total mass of the reactants will be equal to the total mass of the product. Chemical reaction only break down the previous bond, chemical bond that was in the reactants, and produce a new substance with a new chemical bond. It is actually the rearrangement of atoms and molecules. You understand? We will discuss in the equation part, chemical equation part. There is a branch of chemistry that is called stoichiometry, that ensures that in your equation these are balanced. Moles, masses, molecules, volumes of the reactants must be equal to the moles, masses, molecules and volumes of the product. We will discuss it in a later period. Let us now see one reaction. I told you that we will discuss it in detail. That can be done in the... What happens when a reaction takes place? How can we know that chemical reaction is taking place or not? It is not a physical change, but it is actually a chemical change. Because sometimes there are some characteristics that are common to a physical change and a chemical change. Because in physical change, the change of state happens and sometimes we have already seen that in chemical changes also a change of state happens. But how do we know that this was just a physical change? No rearrangement of atoms and molecules are there, and this change of state is a chemical change. The atoms and molecules are being rearranged. Let's look at a simple experiment. Simple experiment in the laboratory, not at home. Let us take a conical flask and put a pipe through the cork, glass, and put some zinc granules. Very small pieces of zinc metal, and let us pour some very diluted hydrochloric acid or maybe sulfuric acid, that doesn't matter. Actually what we are going to do is we are watching the reaction of an acid on a metal. The moment you put some diluted acid on the zinc metal, you will see that very briskly, very quickly, some gas bubbles begin to form. And these zinc granules, they will very soon change to another compound called zinc sulfate, ZnSO4. But this gas, it will definitely come out of this pipe. What is this gas? If you put a burning match at this end of the pipe, you will see that the gas is burning with a flame. The gas itself is burning with a flame. It proves that this gas is hydrogen. Now, this experiment shows you two immediate effects. One is that a gas is formed. A gas is immediately formed. And you also, if you put your hand on the flask, you will see that it has become a little more hot. Its temperature has increased, although you have not put any fire or heating apparatus to it. These are the two characteristics that proves that this is a chemical reaction. At your home you can also see that if you take some lime, lime, quick lime, we call it, tuna, and add some water in it, it will actually change into calcium oxide plus water, changes into calcium hydroxide. But with it you will know that it also evolves from heat. It becomes hot. Tuna, if you mix pani with it, it becomes hot. It changes to slaked lime. Quick lime plus water equal to slaked lime. Now this is one characteristic or property of the chemical reaction. It involves heat. It either becomes hotter or becomes colder. If through the reactions temperature is increased, heat is produced, we call that kind of reactions exothermic. Heat giving, heat generating. Like these two reactions, they are heat generating or exothermic reactions. The opposite may also happen. The opposite may also happen like this. Say, we also discussed this a little previously. Suppose we take a test tube at laboratory and put 2 grams of barium hydroxide, 2 grams. There is a proportion, you know also that a chemical reaction must happen when some proportion, law of proportion is there, maintained. And 1 part, 1 gram ammonium chloride. What will happen? We have already seen in the experiment part. But if we start this solution with a glass rod, you will feel that the test tube has become colder. This experiment and exhausts it. Such reactions are called endothermic. Endothermic. Heat absorbing. So this is one of the characteristics that you will know that the chemical reaction is happening. Chemical change is taking place. Also the evolution of gas. Now let us quickly look at a list of the basic characteristics that can be noted by naked eye, open eye, when an experiment or a reaction is taking place. That is a chemical reaction. Please look at this slide for a minute. So in this experiment, we are saying that a silver nitrate solution, AgNO3, Ag stands for argentum, silver. It is mixed up with sodium chloride, NaCl solution. What happens is a precipitate forms in the form of AgCl, argentum chloride, silver chloride. It is precipitate. And sodium nitrate is forms in the solution. In the second experiment, that is in the picture 2, we see that a barium chloride, BaCl2 solution is being mixed with sodium sulfate solution, Na2SO4. What happens is that there is a salt solution, NaCl, sodium chloride solution is formed, but also a barium sulfate precipitate comes down, BaSO4 precipitate comes down. And these are the some examples of how precipitates are formed. Now, we have already talked about how gas is formed during some chemical reactions, particularly the reaction with the zinc solution and acid, zinc granules and sulfuric or hydrochloric acid. We have seen that hydrogen gas is evolved. In the same way, we also have seen that calcium carbonate, when heated with calcium dilute hydrochloric acid, carbon dioxide gas is evolved. So now the third part. Change in color. Change in color, we can give you examples by 2 experiments. One is when we put lead nitrate, a colorless solution, and react it with potassium iodide, which is also a colorless solution. These 2 reactants react to form lead iodide, a yellow solution, and potassium nitrate, a colorless solution. This change in color, yellow, in the product. And another common example is rusting. When iron rusts, it becomes brown. So these are the examples of change in color. Change in state. Like if you burn a candle, solid wax,
the reaction will be like this. Solid wax burnt in oxygen, that is C25H52 plus O2 burning. It will produce, carbon dioxide and water, CO2 and H2O. Likewise, if you are burning petrol, when it burns, its formula is like that, C8H18 plus O2 equal to, again it forms carbon dioxide and water, vapor. Now finally we come to the changing temperature. This we have already seen, the exothermic reaction, how if you put water in calcium oxide, quicklime, you mix pani with tuna, it becomes hot while forming calcium hydroxide, slaked lime. And also the opposite, we have seen that if you take 2 grams of BaOH2, barium hydroxide, and 1 gram of NH4Cl, ammonium chloride, what happens is that the temperature gets down, heat is absorbed. This is an example of endothermic reaction. Okay?
So, you see, let's sum up now. For this period, I will break the whole lesson into 2, 3, maximum 4 periods, small periods, so that it's a very important topic. How to write an equation, how many kinds of chemical reaction can happen. It's the basic part of chemistry. You are actually getting inside the chemistry subject from this chapter, because chemical changes are the main subject of chemistry. That's obvious. Physical changes are not the main part of chemistry. So let us understand it part by part. Do the exercises I provide. Let me sum up those 5 points. The characteristics of chemical changes. Which characteristics will tell us that a chemical reaction is taking place? There will be a change of state. There may be a change in color. There may be change in temperature. And we have already seen that it can be heat generating and heat absorbing, endothermic or exothermic. There sometimes a gas is involved. And sometimes precipitate forms. What is a precipitate? Precipitate is a solid part that forms when we mix 2 solutions. When 2 solutions chemically react, sometimes a solid precipitate that comes down, falls down at the bottom, we call it precipitate. These 5 are the basic. If more than one or all 5 can take place in the same chemical reaction, or only one. Like we saw in the zinc and acid reaction. There was a gas evolution. There was a change in temperature. So, you see, up to this point, you should go again and again. That's why we are keeping this video a little short. Again and again, and do the exercises in your book that involve this part of the teaching. We will meet very soon in the next part, where we will learn how to express these chemical reactions through equation. A very important part, the stoichiometry part. Right? Till then, stay home, stay safe, and utilize your time properly. Thank you.